we've got question 4, also from the 2019 paper. Remember, we are revising the November paper 2019, and this is paper number 2. So this one is from Equivalent Darsal. Yes, I hope I'm saying that, Equivalent Darsal. I know you had problems with question number 4, my darling. And with this question, it's usually when they give you an alcohol moves into something, this is the reaction type and so forth. Unfortunately, to simplify a question like this, you will have to keep redrawing as you move from one to the next. But I'm going to show you how we've done it. Let's look at this one. So for question 4, we have a flow diagram that represents compound A, and it's prepared. Let me just write it out. We've got the flow diagram. Have the flow diagram below. And this shows how compound A how it can be used to prepare. Remember, if you're preparing something, you need ingredients. Prepare other organic. So already you can see it's going to change compounds, organic compounds, and then the numbers. Again, here in the diagram that I'm given, they've used numbers, the Roman numerical numbers. You keep to these Roman numerical numbers, and then they represent different organic reactions. Reactions. Okay, already I can see the word reactions. I want to stress something with you guys. When we talk about different types of organic reactions, remember we get addition reactions. What are you adding? You can add a hydrogen gas, you can add a water, you can add this, and so forth. Then we get elimination. And then remember, when you are eliminating something, or if water and something then is formed, means something was taken away, right? And you get dehydrogenation and all these different things. Now, the key words are in some of these words. Then you get substitution reactions. When you are substituting something, you are actually bringing in something in place of something else, right? If you are adding, you could be breaking a double or a triple bond, and you are adding something to that molecule. So now with these types of reactions, they do get a little bit confusing, but let's see how we can figure this question out. So now I've been given a diagram here, and I've got compound A. I've got compound A, and then here I've got reaction number 3, and I've got a primary alcohol. Okay, now because we've already looked at primary alcohols, we know how primary alcohols look. It's one carbon attached to the centrary carbon. Then I've got IV, and then here I've got CH3COOH. Now, already just by drawing this, by mere looking at this, I can already see the functional group in which it belongs. Then I've got organic compound C. Organic compound. I've got C, and then I draw this side. Then I've got KOH. And then here I'm given a structure. This is where your key points come from. C, I've got another C. Remember, your carbon must always have 4 lines around it. That's got 3, so I must put another one there. Let's see. And then at the bottom, I'm told this is 2, and this is hydration. I'm told this is hydration, and this is compound B. Compound B, and they've also given me a clue to say this is the major product. If you see major and minor products, you think of Markovnikov and you think of Zaitsev, right? These are the people who lead us to this. So before we answer this question, guys, I actually want us to look at it. So we've got compound A. Now, I don't know what this reaction is, but whatever happens here to compound A, it then becomes an alcohol, right? Now, I can already think if something is concentrated in sulfuric acid, it could then help me get it to be an alcohol. And then I can see the functional group that is there. This looks like carboxylic acid. And then I've got compound C. So this carboxylic acid with this alcohol must do something. Already in my mind, based on what we've learned in chemistry, when you have an alcohol, when you have a carboxylic acid, how do I know this? Because the COOH, we can do an ester. We can have an ester. That's what I'm seeing from my left-hand side. On this side, I've got KOH. I can see, okay, this is a concentrated base. I've got a double bond. So whatever compound A was, something must have happened to it. And then something must have been eliminated because now all of a sudden I've got a double bond. On this alcohol, I don't see any signs of double bonds, but I've got a double bond, so something must have been eliminated. Then we've got hydration. Remember, when you hydrate, you drink water. And then I've got my major product there that is then formed. This is what I'm given from my diagram. So let's see. If I've got 4.1, let's see what question 4.1 says. It says we must name the homologous series. We must name the homologous series. The homologous series, this is to which compound A belongs. Okay, this one's pretty easy. Belongs. Now, we are not given much, but we know here it was an alcohol, here we had a double bond. So these are usually alkanes, haloalkanes, right? It means that they should have one or more halogen to them, because if it can be an alcohol on this side, something must have been eliminated on my right-hand side. Then it must mean it's a haloalkane. It's a haloalkane. Some call it alkali halides, right? Remember, it means it must have been an alcohol. Here it's a double bond. It means that it must have a halogen somewhere, which is then an X. And this is actually what we learned in grade 10. So that one was very easy. That was for 1 mark. Let's see what happens. Now they want us to give the types of reaction. Okay, this is going to be nice. The type of reaction. So I've got 4.2.1. Miss Woman just writes it all out. 4.2.2. And this is all counting 1 mark. Okay, but we can already see just by mere looking and how we have identified it. So for 4.2.1, they've given me this Roman numericals 1. This is 1, 2, 3, and this is 4. So let's see where the first one. Let's see where the first one is. Oh, I left the first one out, which is there. So now let's think, right? I had compound A, which had something in it. What did we say in chemistry? If something, in soccer, if somebody is eliminated, you play with less players. In chemistry, if something is eliminated, we close that gap by making a double or a triple bond. Right now, I can see that there is a double bond there. So this means this must be an elimination reaction. Elimination, very easy. This is elimination, right? You can also say dehydrohalogenation, because if compound A is a haloalkane, it must have an HX somewhere there. But it's an elimination reaction because something was being eliminated. Let's look for the third one. Now, I've got compound A, I've got something that happens to it, and then I've got an alcohol. I can see it's not showing me that a double bond was formed or a triple bond was formed, but something must have been taken out and something must be replaced. Remember, an alcohol has got an OH. So it means I could have had maybe a chlorine, a fluorine, iodine, or whatever, and then I could have replaced that with the alcohol, right, to change the functional group. So this means it could be a substitution reaction because it doesn't show me something was removed by a double bond. A substitution reaction. It's a substitution reaction. Remember, with substitution reaction, it's also the conversion of haloalkanes to alcohol. If a haloalkane is converted to an alcohol, already in your mind you must ring substitution, and so forth. So now let's look at the last one, which is the fourth one, and which one? This one's here. Now, like we said, I've got an alcohol here, and COOH is a carboxylic acid. Now, I know from the alcohol, I can lose the H. From the carboxylic acid, I can lose the OH to give me water, which is H2O. And what is left is an ester. And the formation of an ester is what we then call esterification. And that is the reaction that takes place there. Esterification. You can also say condensation, but esterification just sounds more, yeah? So how did we find this? With the first reaction, I have compound A. Something happens to it, but it already now it has a double bond. If anything forms a double bond, something was eliminated. Even though we don't know what was eliminated, but something was eliminated. We see this by the double bond. For the third one, which is here, I've got compound A. Now it's an alcohol, but in this side, there's no alcohol. It means whatever was replaced, let's say something was sitting in these two parts that was eliminated. They must have been substituted in this side to make this compound an alcohol. That's why we say it's a substitution reaction. For the fourth one, which is this side, if I've got an alcohol, and then I've got this belongs to carboxylic acids. Right? I can see that by this homologous series, by the functional group that it has. An alcohol with a carboxylic acid, and then it forms compound C. If an alcohol comes with a carboxylic acid, we form water, and then we get an ester. We all know the name ending will be O8. So that's what equivalent dorsal. This is then what we had to find with this one. So let's go to another question. So actually an interesting question paper. So now we've got 4.3 and says we must consider reaction 4.3 says we must consider reaction 3. Consider reaction number 3. And we have 4.3.1. Now we need to name two reaction conditions. Conditions for this reaction. Now, I want to take you back a little bit when we talk about reaction conditions. Let's talk about when we were doing Le Chatelier's principle and chemical equilibrium and so forth. We knew that pressure needed to be present, or pressure could be changed. We knew that temperature needed to be in a different temperature for things to occur. When they are manufacturing ammonia, sulfuric acid, and so forth, we require a catalyst to speed up the reaction. We require certain amounts of temperatures. I mean, temperatures can go up to 900 degrees Celsius. But at that point, at that temperature, then we can say ammonia or whatever was then formed. So for certain reactions to take place, things need to happen. And you can ask me, okay, Tops, but what do you mean in our everyday life? If you were trying to cook pap and the plate of the stove is cold, are you going to get far? You're not going to get very far. You know, you're going to mix and you're going to mix and you're going to mix because the plate is not hot, right? So for you to actually cook pap, you need boiling water and you need the stove to constantly be on so that it can cook through. That is one of the reaction conditions for you to actually cook pap. So again, when we look at reaction number 3, let me go back here. Reaction number 3, it's this one. For this haloalkane to actually move to an alcohol, there is a type of condition that needs to be present. And now, remember, for it to move to an alcohol, we need heat. This is very simple. We need heat, we need a strong base, and then we also need water. We need water. Remember, water is H2O and an alcohol is OH, which actually makes sense. So these are the conditions that need to be there. This was for 2 marks. The examiner wanted to see whether you understand that for certain reactions to take place, this is what was required. And you could have just named them in bullet point. They didn't say explain and whatever. They just said name the 2. The next one, which is 4.3.2, it says we must give the IUPAC. We have IUPAC again. IUPAC name of the primary alcohol. So now, remember, this is where I'm going to get it from. Yeah, let me use this color. I'm going to go back to this one here. Which one has given us the most information in this diagram? Here I just have a known name. It just says primary alcohol, but I don't know what primary alcohol is. Remember, even though it's a primary alcohol, it could have 6 chains, it could have 10 chains, it could have 11 chains, but it's a primary alcohol, right? It doesn't give me a name. This one just gives me an organic molecule. There's no name, I can't see the chain, nothing. Compound B just says compound B, and then there's a major product, but where I get the most information is It's this one here. I've got 1, 2, 3 carbons. Remember, let me take you back. I think it was question 2 when we did isomers, right? It said isomers, the position can change, the chain position can change, the side chains could change. However, it is the same molecular formula. The number of carbons doesn't change and the number of hydrogens doesn't change. So if I'm looking at this, if this was compound A, here it becomes an alcohol and something was replaced with it, or it was substituted with it, then I can say it also has 3 hydrogens here. This has got 3 carbons at the end, right? So it means that this alcohol will also then have 3 carbons. So let's do this one quickly. So I've got 3 carbons, 1, 2, 3. How do we know something is a primary alcohol? It means on this hydrogen here, we're going to have OH. And if this is the first carbon, a primary alcohol must be attached to one other carbon. So this means this will be my primary alcohol. I had to look at the part of the graph that had the most information. Let me just put my hydrogens. I had to put it on the graph. I had to look on this graph to find, okay, this is how my structure looks, but it can be an alcohol, it can be a compound B, we can go through hydration and form compound B or whatever. But the number of carbons and hydrogens does not change, right? Okay, in this case it changed because something was eliminated, but the number of carbons does not change. This is then how I could find my primary alcohol. I know my theory of primary alcohols to say that the carbon attached to the OH must be attached to only one other carbon. If it was a second alcohol, I would have had 2 carbons attached to the primary alcohol, to the first alcohol. Now let's name it. How many carbons do I have? 1 is meth, 1 is meth, 2 is eth, 3 is prop. So I can say prop, propan on the first one, which is 1. There is what? There's an alcohol. Name ending for alcohols is an ol. So it's propan 1 ol. That's how the name will go. Let's look at another part of this question. Then we have 4.4. And 4.4 of this question says we must draw the structural formula of B. We must draw the structural formula. Remember already when they say structural formula, you think the number of hydrogens around the carbon molecules formula. Structural formula for compound B. Let me just go back here. We were over there. So this is the diagram that we were given. So for number B, what do I know for number B? I know that we have this structure, there's a double bond, and then we hydrate. Remember, if you are thirsty after a long marathon, we say, I want to hydrate myself. When you hydrate, it is water. You are taking in water. So I can already see with this molecule here, I'm going to add water to it, and then I'm going to get B, and I'm going to get my major product. Remember, major and minor products, we talk about Zaitse's rule. So the best thing to do, my darlings, let us draw it. So the first structure, it initially looks like this. Let me just go back here and just double check on that. Yes, it's on the first one. So we have a double bond C there. We've got another C. And then we have our hydrogens that are connected to it. Initially, the structure looks like this. And then they are telling us that we need to add water. And remember, water is H2O. And water will dissociate into H plus and into OH minus. Now, remember guys, this hydrogen, according to Markovnikov and Zaitsev, it will attach to the self with the carbon with the most number, with the most number of hydrogens, and this one will attach to itself to the carbon. It will attach to the carbon with the least. This is just rule of thumb. Carbon with the least number with number of hydrogens. So remember, we had eliminated something, so now we need to break this double bond. So I break this double bond, and then this becomes a single bond, and then these two will then sit on there. But how do I know where this goes? here on this carbon, I have one hydrogen. On this carbon, I've got two hydrogens. This hydrogen will attach to itself to the carbon with the most number of hydrogens. Between these two, this one has two, this one has got one, this one has the most hydrogen. I'll have my H. My OH will attach to the carbon with the least number. If these are two, this is one, this has the least number, so this will become my OH, or that is where my OH will then attach itself to. So if we had to draw the structural formula of B by hydration, that is the type of reaction, this is then how you will go about. Remember, you can actually move this O to this side and this one to this side, but because B told us that we must form the major product, that is then the rules of chemistry that we need to follow in order to form the major product. So, okay, the next question, let me actually go to a different slide. I think I might need space. They want us to consider reaction IV, which is 4. Just want to take you back. This is this reaction right here. This is this reaction right here where we move from the alcohol. We've got an organic compound, and then I've got this compound right there. Remember what we said? The reaction type is esterification. So now let's see what they want us to do. 4.5.1, we must draw the structural formula. Must draw the structural formula. Now, you must remember, when you have an alcohol and you have a carboxylic acid, you must form water. But I think the crucial or the most important part to where the hydrogen will come from and where do you take the OH is very crucial. Something you must always remember. From the alcohol, you take the H and you leave the O. And from the carboxylic acid, you leave the O and you take everything else, because when you name it, you also have to do the same. So let's see how we're going to get this right. So here, let me do it the long way around. So me doing it the long way around means I'm going to start with this structural formula here. Let me just go back to our reaction. Remember, this was our alcohol. We drew our alcohol in the previous slide, if I'm not lying. Okay, I can't remember which slide we drew it in. Oh, here we are. Here is my alcohol that we have drawn in the previous slide. And then now I need to draw from this reaction here, this compound here. Now I'm going to bring those two together. This is how we're going to do it. Oh, this is how I would tackle this question. The alcohol that we had, remember, pentan 1O was C. We said it's attached to the first carbon because it is a primary alcohol, and then it has the hydrogens around it. Then the next one, I have the C. I've got another C, but it's got an OOH. I've got a double bond O that is attached to an OH. Right? Then I've got 3, 4 carbons, so I need to have hydrogens on this side. Now we need to consider and draw the structural formula. Remember what we said, esterification must form an ester. If this is your alcohol with the OH, you lose the H. From the carboxylic acid, you lose the OH. Now we know if I've got H and OH, I've got 2 hydrogens, and oh, there we go, my water is produced. Now I'm going to take this part away. I'm going to take all of this away, and I'm going to rejoin these two together. This is how I'm going to do it. I've got 3 carbons, which is 1, 2, 3. I'm left with an O. Let me just put my hydrogens there. Otherwise, it does not make it a molecular formula or a molecular substance. Got my hydrogens there. Then I'm going to bond it to this one. Remember, this is now gone. I'm bonding it to the C. There's a double bond O. I've got another C, and it has its hydrogens around it. Now, how do you know this is correct? Remember, if you talk about an ester, you need to have an O in the center with a C bonded to a double bond oxygen. That is then esterification. This was actually a pretty interesting question. Now we look at this one. Now we're going to have 4.5.2, and it says name. It says name or formula. It says name or formula of the catalyst. Catalyst is used. That is used. And this was just going for 1 mark. Now, let's just talk about catalysts. Remember, when we're talking about a catalyst, certain reactions, as we have said before, need certain restrictions. Certain reactions need to have heat, like if you are making pop, you need to have heat. Certain reactions don't need heat. Certain reaction needs to have, the particles have kinetic energy so that they are bouncing around, so that we can have collision theory and effective molecular formation with molecular orientation and so forth. And certain reactions require a catalyst for them to take place. What is a catalyst? Remember, a catalyst, these are substances that speed up the reaction rate by lowering the activation energy, but actually do not take part in the reaction. For an example, if you are hosting a braai at home and so forth, and the fire is taking forever, then you can add fire lighters into your fire to actually speed up the fire. But your meat is not actually coated in the fire lighters or anything. It just speeds up the heat or the fire that you are trying to make, right? That is then a catalyst. It speeds up the reaction without actually taking part. So now they are asking us, we must name or give the formula of the catalyst that is then used. So now if I go back to this diagram over here, and what catalyst will then be used between an alcohol and a carboxylic acid, and then we know this is concentrated, and I think the word concentrated is very important, concentrated, because remember, you can have something that is concentrated, and the word concentrated means little to no water, and something that is diluted means there are water particles inside. So if you are saying, let me just write down the whole answer, then you'll know what I'm talking about. This is concentrated H2SO4. SO4 is sulfuric acid. Or you could have said concentrated. They said name or formula. So if you forgot sulfuric acid is H2SO4, you could have said concentrated sulfuric acid. So it is very important that you state that it's concentrated sulfuric acid and it's not diluted sulfuric acid. Remember when we did acids and bases, we spoke about how sulfuric acid is a corrosive acid. It's a corrosive acid and it will dissociate completely. However, in a reaction, if the acid is diluted or concentrated, it actually acts then, it will work differently. So you must say it is a concentrated sulfuric acid and then you would have gotten your 1 mark.